Okay. By the way, friend. So your project is about impact assessment. Is that correct?
Yes, okay.
Okay. Can you show me the map or something so I can advise you?
Sir Nev was the one who
Hmm?
do the math. Nev, our other group mate, is not in the family. So he was the one assigned to do the map showing the 1 kilometer radius.
Oh, okay. So your
So
other group mate did not join. It?
unfortunately, yes. But I would like to ask, using that 1 kilometer radius, are we going to do the traffic impact assessment on each intersection?
So traffic impact assessment. So if you can show me the map, then we can discuss more detail. The one that you show in the class, is that possible?
Yes, we can show that in the next class. So, every college and I'm going to do. So,
Your voice is not clear, and then your video is closed, so I cannot hear you.
this is better.
If at least if you talk, I can cut your mouth, but I don't hear you, and then you close your video, so I don't know.
Hello, so, can you hear me?
Okay, if you speak slowly, I can cut your mouth, so I can understand.
So now that we use the region to 1 kilometer,
Okay, you make the traffic impact assessment of 1 kilometer. So you can get the boundary, right? Do you know how to get the map?
yes, yes, sir. We already got the map and the boundaries of
Okay,
the one
so
kilometer radius.
right.
And then,
If you get the online IFN transport, you can set the boundary like top bottom, and then you apply to the map, right? Okay.
sir, uh, for the online IFN transport uh, gathering of data, do we do that for each intersection in the map or just specific areas? Just specific
Okay.
points.
So I cannot get you. Wait a minute. So let's go to the IFN transport. Okay. And let me share with you the online IFN transport. Okay. Can you see this? So you go to the map and go to OSM and then tell me your project name. What is the area? Can you hear me?
Met Live
Net live,
sir.
net live, like this.
Met Like
In what?
3.
Okay, you type in the chat. So,
I
okay. Math line. Okay. Math line 3 outside. There is none. Is this the one? Is this the one?
Yes, sir. This is near MOA. Yes.
So which one is your project placed? Okay, so where is your boundary? You need to tell where is the boundary. This is the
In the presentation last Friday, sir, we are aiming for the intersection near the Met Live 3. That is around the Double Dragon. Wait, can I? um, Here, sir, in the what's this? There,
this,
sir.
this is the
That
place.
intersection. Yes, that's the place.
Okay, so this is the place. So in that case, you need to go at least one intersection here and then one intersection here, right? And then this one until here. Is that correct? So
Yes,
in
sir.
so I will zoom out. Okay. So at least okay. But this is okay until here. Is it okay? The map, the mall in the
Yes.
center. This is the center, right? No. Okay. So you go to
Yes, sir.
airport. This is the one. So I will put it like this. So now you copy this. Okay. In IFN transport up, right, left, and bottom. Okay. So let me first go out all, and then I will not clean first, and then I download everything. Okay, so it's download. Okay, so you get if you download everything, you get like this about 4,000 data, and these are your data. So the scale is still very bad, so I will put 50,000. There, this is the one.
Yes, sir.
Right, this is the circle, right? So now you can use GIS software. Okay. Did you learn GIS already? So you can clean up all this part of the map, and down here you don't need to use. Okay. And you clean up your map up to here only. Position not connected. You can also remove, for example, from this is small road, you don't need to. So you can clean up. Okay. So alternatively, if you go directly here, okay, say you don't want us classified living residential, only the big one, you can also download directly. So just click this button. There. So you get 3,000 something. And now cleaner, but you can see that there are a lot of unconnected part there. So we can clean that one, clean to the strongly connected network. This option. Or you can go directly in the map. So this is very big. So okay. Oh, now clean. See? So check. Oh, this is already strongly connected. And this is the one that you can use. Is this okay? So your area is here, right? So you can use this map. So all you need to do is you go to the aerial flow with maximum congestion, say for example 0.9. Okay, and then you can test it. So result, you just calculate. And just with there, got it. So you got everything already as a base scenario, okay, including the flow, including the congestion level. This is in percentage. Okay, now you can download this at the bottom. And you can select the congestion. There, you can start to see we have about 25,000. So I think it's all green now. It's not really congested yet at this point. This one is the most congested area. Okay, so this one, can you see? So this is actually the most congested area, where your project is actually here, right? So, and then this is like the base scenario that you have, okay? And what happens if you have a new development here? So then you go to this map in then so for the TIA, you probably want to get the area of its building here. Okay. So if you use GIS, you can get the area of each building here. And then you need to get the data of whether they are residential or they are actually commercial area. Okay, so residential will be the trip production, but and then commercial area will be the trip attraction, right? And then you divide all the others outside also, okay, of the area in this map. So you can create a zone outside of your mall. So you can divide, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, probably 10 zone. Okay, and outside. Okay, and then you can create trip generation, trip distribution. Okay, and once you have that, you can calculate traffic assignment in this software. So you have the OD matrix that you can set. And if you have the OD matrix, so you can use capacity restraint and you input the OD matrix here. Okay, so this is node 1, node 2. So you put the capacity restraint. What is your first node, second node? The node must be the same exactly like this one. This is the name of the node that you put. For example, this one. Oh, this one. So this is the node ID. Okay, this is the coordinate. Do you get it? Okay, this is your node ID. So if you have that, so the first is the node ID, this is the node ID, and then the flow is from the gravity model. Okay, this OD flow is from gravity model. Once you have, you use this capacity restraint. Okay, this is already fine. You can use screen sheet also if you want, or you can use PPR. So that's it, and then you just click calculate, and then you can get the result of your base case. Okay, once you have the base case, what you need to do is actually create new map. So this one you save. Okay, so this is the save scenario. Okay, so and then you make a new map. Okay, based on the base case. Okay, what is the alternative scenario? So in that case, for example, oh, I will widen this road, or I will make this road no parking and so on. So that is the alternative scenario that you will put, okay, in order to improve the situation in the future. Are you okay with that? So you project, okay, this year, okay, and then offer in the next, say, 30 years or 20 years. Okay, what will be the trip generation and trip attraction here in the area based on the population and the land use change. Okay, so and then you calculate the trip distribution here. Give me feedback if you don't understand. You understand trip generation or not?
Yes, sir.
Okay, so based on the trip rate and you calculate by the area of the land use, then you can get the trip gen, right? Trip distribution, you simply use the gravity model. I already did give you last time, right? So you just put the trip cost and the trip production and trip attraction, okay? And you can set your alpha, beta, and so on, and click calculate. You're supposed to get the distribution like this, right? So this is the one that from O to D. This is the one that we put in here in this O and D, and then the flow. So This is the flow that you need to put. That is you do for base scenario and then alternative scenario and alternative scenario 2. Okay. And then for each year that you are projecting. So with that, you will know whether your proposed scenario is actually better or not. So how do you know? You can see the result. Okay. For example, the simplest way to do is to check this one, the maximum congestion level. Okay. If the say if you don't have data, okay, you can set the maximum congestion level at 90, for example, initially. Okay. And then once you put the alternative scenario, this is supposed to reduce, right? Less than 90. Is that okay? So, and over a different course of years, okay? So this one probably more than 90 because more generated, more population and higher economic. Okay. So you can set initially whatever number. For example, 80 is okay. Up to say 100%, right? At the projected year. And then when you put alternative scenario, okay, that for the same year, a base year and alternative scenario, the alternative scenario should be better, right? Do you get the idea or not?
Yes, sir. Victor has a question in the chat. Po.
Okay, so we need to have one base for each year. Okay, so how many alternative? At least one, of course. Okay, at least one alternative scenario that should be okay. But I'm telling you, the most difficult part is not to create the base. The base you can just download from the map, right? So to create the alternative scenario, you need to change the map. So this is the initial value. So for example, the one that you change, for example, the capacity, based on the number of lanes, for example, you change the capacity. If you increase the lane, so one lane is 1.5 in here. So this is like 3 lanes, right? And this is like 4 lanes. So if you change, for example, the traffic signal, again, the capacity change, right? Or the traffic signal, maybe the stochastic change. Okay. Okay. So that is the one that make the difference. So the question is, how are we going to make the alternative scenario? Okay, if the base year is 90, your alternative scenario is actually less than 90. For example, 87 or 85, that's okay. So actually better by 5%, better by 10%. So finding alternative scenario is very difficult because you need to try and error. And then run again, right? So in that case, what you need to do is to divide in the groups. Everyone will knows what to do, and then everyone will select different alternative scenario and then run, and then check whether this is actually improved or not. So in the modeling, the most difficult part is not to collect data, actually to find the alternative scenario that improve than the base scenario. So if you have several alternative scenarios that actually improve, then you can find the optimum one. Of course, the highest improvement. That is the one that you will propose, right? So I hope this is clear enough. Yeah. Getting the data is not difficult at all. So if you have the real data, so you can also include the real data. Okay. So here, say using IFN, you can have the real workflow. You can also have the OD. So this is the OD matrix. This is the actual flow. This is the one that you collect from the data, the actual real world at this base year only. Of course, you cannot collect in the future, right? So this is only base year. And the purpose of this collection of OD and base year is just to get the base year model, okay? So that you will get all this performance index. Okay. Once you finish this, for the future year, of course, you don't have the OD, you don't have the flow. So you can use the model parameter here as your assumption. For example, okay, you set your congestion level and the total flow here. Okay. So this is the one that you will input, either total flow or the maximum congestion level. Yes, so you simulate, that's correct. Okay. Super. Okay. So, but the most important part to collect the alternative scenario is you will put in the same year, total flow is the same. Total flow means the actual demand for the entire network, right? So the total flow will be the same. So in this model, okay, for the alternative scenario, you don't use the OD anymore. So you use total flow, or you can use the maximum flow, or you can use maximum congestion level for the alternative scenario. Okay. For the alternative scenario, you don't use OD, you don't use real world flow, only for the base. Because in the base model, you want to get that model parameter. You got it? So in here, the model parameter is total flow and maximum congestion. Okay, maybe the network speed and network distance. So these are the say average. These are the parameter that you will set for your base scenario. Okay. After that, so for the alternative scenario, okay, you will put, say, the total flow exactly the same as earlier. So in here, example, I have 710. So I will copy this. So total flow, I'll just copy that. Okay. Once I put this, okay, and the network change, okay, some of this link now change. Instead of, for example, 4.5, now I make it 6,000 or something. Right? So this one you change the scenario. Then you can run again. Please ask me question if you understand. Is this helpful for you, or you want to say something? I will exit the place because this is getting bad. Okay, so tell me what you get, and you want to ask question. Don't hesitate, okay? Format, format is up to you. Yeah, yeah, of course, the format is a paper and the report, right? Yes, you include everything. Mm. Format, you include everything. It's just like report of TIA. So the most important part is to find the alternative scenario that is better than the current one. So for that case, you need to divide the group, the job into a delegate, no? So each person will run several scenarios. To do that, you need to do the base scenario first. Again, traffic count is not needed. I don't, I want to give you the idea that you don't really need the traffic count because you focus on the data. Okay, we are in the modeling class, we are not focused on the data. The data you can put, for example, instead of getting the real flow, you can just set 0.9 in your congestion level as the base scenario. You don't even need data. Okay, so you need to model first. Okay, for example, the trip gen, you need to model, the trip distribution, you need to model, and then you project it year after year. And how the land use change, you need to model that. Okay. Simplified model with just trip rate is fine. So, and then for the same year, you have the base case, okay, and then you have the alternative scenario. So for the base case for the future year, for example, you get the projected OD, right? And then for the alternative scenario, you don't need so any data except for the model parameter for the base year. Okay, for example, total flow or the maximum congestion that you set there. So the best way is to create the total flow. The total flow means total demand of that year. Okay. And then you put that in the alternative scenario, and then you will get the result. And then you compare. Oh, this alternative scenario actually improve. Oh, this alternative scenario not improve. Even not improve, you can report, no problem. So that we will know that you have done something. Uh, Tell me what you get and what you don't. Hey, this is not class. This is a consultation. You're supposed to ask questions. Uh, that the timeline you check the course syllabus is already in the course syllabus. Yeah, I think by the mid of next month. Is that correct? Or in the beginning of next month. So this is very short time actually. Do you get how to do it, or you still got confused? Really? Okay, clear? Okay then, if clear, if everything clear, then we can stop our meeting. So, okay, thank you.
Thank you, sir.
Thank you. The recording, okay, I will send you.
Sige po, sir. Thank you
Yo,
po ulit.
okay, bye-bye.
Thank
Have
you,
a
sir.
nice evening, everyone.
So, anytime.